Cancer is a disease that affects millions of people every year, and despite numerous medical advancements, we do not yet seem to have a cure. So it begs the question, can we or will we ever cure cancer? Now, in order for us to understand why our bodies have a hard time fighting cancer, we first need to look at how our immune system typically works. Now, our immune cells are activated when they detect the presence of a foreign antigen, and an antigen is a protein that sits on the surface of a cell and acts sort of like a flag. These flags allow us to distinguish between good body cells or nasty foreign cells. However, when it comes to cancer, cancer has developed quite a crafty technique of cellular camouflage to evade this type of detection. This type of camouflage is good, but it only really works if I'm in the right environment. Cancer's camouflage, however, allows it to hide anywhere in the body. This camouflage stems from the expression of a protein receptor on the surface of the cancer, and it gives cancer the power of camouflage by binding to a complementary protein on the surface of an immune cell. We call the protein on the surface of the immune cell a PD-1 protein. This is what the process looks like. Through the binding of the PD-L1 receptor on the cancer to the PD-1 protein on the immune cell, the cancer essentially deactivates the immune cell. Think of it like this: if a burglar were to break into your house and set off the alarm, in order to evade capture, they would need to have the right pin for the alarm to deactivate it. Much like how when a tumour begins to grow in your body, if it is to continue growing, it needs to evade the immune system, and therefore it must have the right receptor on its surface. And if both have the right tool for the job, then they can successfully evade the security systems, and is the reason why our bodies have such a difficult time trying to kill it. However, there may be a hope, and it comes in the form of immunotherapy. Immune checkpoint inhibitors often contain monoclonal antibodies, and an antibody is simply a Y-shaped protein that looks like this. They work by interrupting the binding process as shown. The monoclonal antibody binds to the PD-L1 receptor. By taking away cancer's camouflage, our immune cells can recognise the cancer for what it really is, and as a result, they can raise the alarm to the whole body. In response to this plea for help, your body sends in the immune system's cavalry, which include cytotoxic T cells. Cytotoxic T cells are the cancer killers, and they kill cancer cells by binding to them and injecting a chemical called epiphorin. This is an enzyme that digests the cancer's membrane, and as a result the cell dies via apoptosis. The body is now saved from the cancer, and has been saved by the wonder that is immunotherapy.